morning. Today we are going to continue with vectors. We're going to learn how to add vectors. So adding vectors. Before I start, I want to tell you when we are talking about the angle between vectors, we mean the angle between the tails of the vectors. So when I say the angle between vector A and B is 60 degrees, that means this is vector A and this is vector B, and 60 degrees is the angle between the tails. It's not the angle between the heads or the head and tail or any of these. So we have, when we say the angle between vectors, we mean the angle between the tails. So the angle of two vectors is the angle of their tails, the angle between their tails. Okay, this is the first thing I want to tell you. The second thing I want to tell you is what is the meaning of adding vectors. Adding vectors mean we are getting one vector that has the effect of many other vectors. Like, for example, I live in Milton. In the morning, I go to a coffee shop to get my coffee. Then I go to school to work. Then after school, maybe I went to Shoppers. And then I went to visit my sister, and I decided to sleep over there. So home, to coffee shop, to work, to buy something, then to visit my sister, and I decided to sleep. Okay? What is the resultant? The resultant is the vector. What is the result of this whole thing? It is the one vector that has the effect of all of these. At the end, I started here and ended there. Right? So when we add vectors, we arrange the vectors head to tail. We arrange all the vectors head to tail, and we connect the tail of the first with the head of the last. This is the resultant vector. This is the vector that represents the effect of all these vectors. Okay? So again, to add vectors, we arrange vectors head to tail. Then we connect the tail of the first and to the head of the last, and the arrow closes the shape. Okay, so let us have some examples. Okay, let's say we have vector W and vector B. We need to find vector W plus B. So what we're going to do, we are going to draw vector W. We said that parallel vector with the same magnitude are the same, so I can draw a parallel vector to vector W with the same length. And from the head of vector W, I will draw a vector that represents P. So it will be parallel to P with the same magnitude. Then the resultant will be the vector that closes the shape or connect the tail of the first vector with the head of the second. This is the resultant, and this is vector. Okay, what if I want to draw vector P minus vector W, for example? So in this case, I will draw vector P parallel to vector P. Vector W is going this way, so from the head of vector P, I will draw a vector that represents negative vector W. So vector P W is going this way, vector negative W is going this way. So this is vector negative W. Then I connect the tail of the first with the head of the last, and this would be the resultant. This is the sum of these two vectors. Okay. Let us say we have three vectors, B, C, and A. Right? A. Vector A. And we need to find A minus B plus C. So I will start with vector A. So I will draw vector parallel to A and with the same magnitude. Then I will draw a vector represent vector negative B. So from the head of vector A, I will draw a vector that's parallel to B but going in the other direction. So it probably will be this vector, vector B minus B. Then I will draw a vector that represents C. So the same magnitude as C and up here. And this will be C. Now, the resultant vector is the vector that connects the tail of the first vector with the head of the last one. So this is the resultant of, this is the sum of A minus B plus C. Okay? Alright, so I want to do the next example is very important. Alright, what if I have vector A and vector B, and I want to find A plus B? Okay, and this is the angle between A and B. So I cannot, in order to do that, I have to arrange those to be head to tail. So I have to move this to the head of the first vector. So we said that parallel vector with the same magnitude are the same. So this is also vector B. Okay, the same length and the same direction. Now, when we add this, it will be this vector A plus B. Let us say I want to find A minus B. So minus B, from the head of A, I will draw vector that represents vector minus B. Same magnitude as B, but in the opposite direction. And this will be the resultant of this vector. This is vector A minus B, which is parallel to this vector, which is the same as this vector, so A minus B. So when we have two vectors like this and the angle between them, the diagonal of the long diagonal of the parallelogram, that those are adjacent side in it, is the sum of the two vectors, and the smaller diagonal is the difference of the two vectors, or the sum of A minus B. Okay, so this is another thing. All right, I want to do one more example. Okay, we are going to have a rectangular box. This is a rectangular box O, D, call this vector A, and this vector C, and this is vector B. Alright, we need to find, it says express each of the following vectors in terms of A, B, and C. So I will write vector with head and tail, BC, as sum or difference of, in terms of A, B, and C. So vector BC, this vector that goes from here, the tail is here and the head here, is the same as which vector? It is opposite, the same length as vector A and goes in the other direction, so it is the same as vector negative A. Okay? Now, vector GF. GF. So GF is the same as parallel to vector A and with the same magnitude, so this is vector A. Vector OB. Vector OB connects here. This vector OB. It is vector A plus vector AB, which is the same as vector B. So that's vector A plus B. Sorry, plus B. Vector AC. AC, this one. It connects the vector A and the head of vector A and the head of vector C. So I can say that it equals negative vector A, I make the head here, and vector B. Right? It connects, if the tail here and the head here, and then I draw vector B, this will be negative vector A plus vector B. Okay, vector B, G, this vector. So I want to start from B to go to G. So I go BF, so that's vector BF plus vector FG. Vector BF is the same as vector C, and vector FG is the same as vector negative A. Okay, the last thing is vector OF. It is this vector that connects O and F. So I can go this way, OA plus AB, OA plus AB plus BF. Alright, OA is the same as vector A, AB is the same as vector B, BF is the same as vector C. So I wrote every single vector as sum or difference of vector A, B, and C. Okay, so I will stop here, and this is what I want you to know about this. I will post it and I will give you homework, and if you have any questions, please send it to me. Alright, have a great day. Bye.